This is lesson 106, sequences. On the ACT, there's usually one question out of the 60 math questions that deal with a sequence, either an arithmetic or in a geometric sequence, and then occasionally a summation of a sequence, and that'll be a separate lesson. The SAT doesn't deal with sequences anymore, but it still might be fair game, so that might sneak one in on us, so it's worth studying. But if you're studying for the ACT, you absolutely have to know sequences. Let's take a look at what a sequence is. On the board, you can see the numbers that I have. 2, 4, 6, 8. 2, 4, 8, 16. Those are two sequences. They're an array of numbers. What did we do for the first sequence? Well, we added 2. We went from 2 to 4, 4 to 6, and 6 to 8. In the second sequence, what did we do? We went from 2 to 4, 4 to 8 by multiplying by 2, and then 8 to 16. So an arithmetic sequence is add or subtract. A geometric sequence is multiply or divide. On the sequences, as they set them up on the test, they typically give you a couple of numbers and you have to figure out whether it's an arithmetic or a geometric sequence, or they might tell you, in the arithmetic sequence below, the 4 numbers are listed, find the 7th term. So this one I've given you, the 4 numbers are 3, 7, 11, 15. If it says arithmetic sequence, you know you have to add or subtract. So that's find the common difference between the numbers. From 3 to 7 is 4, from 7 to 11 is 4, and from 11 to 15 is 4. If we have to find the 7th term, what I like to do is draw blanks. They've given us 4, we're going to add 3 more on, and we're going to fill in. 4 plus 15 is 19, 19 plus 4 is 23, and 23 plus 4 is 27. There is a formula to use to figure out an arithmetic sequence. You almost never need to know it, but if you're going for a very high score, you need to know it. So the formula works like this. The number that you're looking for, a sub n, is equal to the starting number, a sub 1, plus the term you're looking for, minus 1, times the difference. Let's fill in our sequence here to see how it works. If I'm looking for the 7th number in the sequence, I start with the first, 3, and I go to the 7th minus 1, which would be the 6th, which would be 6, multiplied by my difference 4. 7 minus 1 is 6, times 4 is 24. 3 plus 24 is 27. We found the right term, 27, which is our 7th term. Let's do the same thing with the geometric sequence. The one I listed out here starts with 3 and multiplies by 4. 3 times 4 is 12. 12 times 4 is 48. 48 times 4 is 192. Let's find the 6th term. You can see that a geometric sequence blows up exponentially a lot faster than an arithmetic sequence, which is just linear. What do we need to do? We need to multiply by 4 to get to each term. 192 times 4 is 768. 768 times 4 is 3072. On the test, you can normally just use your calculator to get to what they want. You don't need the formula unless they're asking for a term that takes too many steps on the calculator. In the geometric sequence, the formula is a sub n is equal to a sub 1 times our common ratio raised to the power n minus 1. Let's find the 6th term. We start with 3. We multiply by 4 raised to the 6 minus 1. That gives me 4 to the 5, which is 3 times 1024, or 3072. We found the 6th term in our sequence by using the formula and using our calculator. That's lesson 106, sequences.